Hello everyone, I am Dr. Anup Kumar Gupta. Welcome you all to my online class on Introduction to Coordination Polymer, the coordination chemistry. This topic basically deals in the class BSc semester 3rd in the paper Chemical Dynamics and Coordination Chemistry. This paper having total 8 units. First unit is chemical kinetics and its theory. Unit 2 and 3 comprises with chemical and phase equilibrium, while unit 4 and 5 deals with kinetic theories of gases and liquid state respectively. Whereas unit 6, 7, 8 are the part of coordination chemistry. This is the complete syllabus for Unit 6 to Unit 8, where Unit 6 deals with the general introduction of coordination chemistry. Before going into content, let me give you a quick overview of what today's session or class will cover. We will start by understanding what are coordination compounds. Then about the some inorganic compounds, that is simple salts and addition compound, followed by difference between double salts and coordination compound. And then lastly we move on the key concept, that is ligand and its classification. So let's get started and explore the world of complexes, ligands and metal ligand interaction that form the heart of coordination chemistry. Now, Alfred Werner is known as the father of coordination chemistry. He developed the basis for modern coordination chemistry. He was the first inorganic chemist to win the Nobel Prize. So basically coordination chemistry is the study of a class of inorganic compounds formed by metal which bound to the certain number of nucleophilic species, that is ligand, through the coordinate bond. Normally inorganic compounds are of two types. First one is simple or ordinary salt, second one is the molecular or addition compound. Simple salts are formed by neutralization of an acid and base. We can see from this example QH plus HCl gives KCl, which is a simple salt, whereas in case of addition compound, two or more simple salts mixed together to give new crystal compound called addition compound. Addition compounds are of two types, double salt or coordination compound. So when two or more simple salt mixed together uh, mixed together and mixed together to form a single substance, this is called double salt. But basically there is a difference when we called it double salt or coordination compound. So double salts are compound which dissociates into their constituent ion when dissolved in water, each maintaining its individual chemical identity. We can see from this example here one simple salt KCl plus another simple salt MgCl to mix together to generate carnallite, which upon dissolving in water produces its all constituent ion, that is magnesium, potassium and chloride ion. Whereas coordination compound is a molecule or ion in which a certain metal atom is bounded to surrounding molecules or ions called ligand. Typically, these compounds remains intact when dissolved in water. We can see the example here. Ferrous cyanide plus potassium cyanide gives potassium ferrocyanide. When we dissolve this potassium ferrocyanide, it doesn't produce its all constituent ion in water molecule. Here we can see only potassium ion as well as a complex ion, that is ferrocyanide ion is uh, obtained in the water molecule. Now What is coordination compound? Coordination compound is a compound of metal with a certain number of species, that is ligand bound to metal through coordinate bond or coordinate covalent bond. Here we can see that a metal is directly linked to the ligand with a certain number of ligand. If the number of ligand it is equal to 6, then it generally produces octahedral complexes. While the number of ligand is 4, then it produces tetrahedral and square planar complexes. Here one important thing, we are discussing with the only monodentate ligand. If the denticity, basically here that coordination number is totally depends on the denticity of the ligand. Another thing is complex species could be neutral and or charged, cationic and anionic. Here we can see from the examples, in these platinum complexes, the charge is 2 positive, then it means it is cationic complex. Here we get the 2 negative charge in these platinum complexes, then it is a anionic complexes. Here there is no charge, so it would be neutral complexes. Now we move to ligand and its classification. A ligand is an ion or molecule which can donate their electron pair to central metal atom in the complex through coordinate bond. Now we know that in periodic table metals mainly belongs to S block, D block and F block elements, while certain P block elements, which is highlighted here, is the only donor atomic sites which can donate their electron pairs in ligand. Here carbon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. Example, we can see in the example all these ligands having the same donor atom which discussed here. Now when we talk about ligand, we must know two things, that is total number of atom in the ligand as well as number of donor atomic sites in the ligand. Here we are discussing with Cl ion, only one atomic species in the linker, while in case of H2 there are two atomic species in the linker, but donating sites is only one, that is oxygen. Now ligands are classified into based on two parameters, that is one is charge and second one is the on the basis of denticity. When we are discussing about, when we are taking care of the charge present on the ligand, it would be two types, neutral or charged. In case of charge, it can be cationic or anionic. From this, from the examples we can see that NO positive ligand, that is basically nitrosonium ligand, it is cationic ligand. H2O molecule, that is aqua ligand, which is neutral in nature, and here halide and halo ligands, which is in anionic nature. The most important thing is the classification of ligand based on their denticity. So basically, what is denticity? Denticity is the number of electron pair donation capability from donor atomic sites in the ligand molecule. So based on denticity, ligands are of two types, basically two types. One is monodentate ligand and another one is polydentate ligand. In case of monodentate ligand, only one donor atomic sites of the ligand donates one electron pair to take part in bonding, while in case of polydentate ligand, more than one donor atomic sites of the ligand donates electron pair to take part in the bonding. When two electron pair from two atomic sites have been donated, then such ligands are called bidentate. Accordingly, 3 electron pair from 3 atomic sites, then it is tridentate ligand. 4 electron pair from 4 atomic site, then it is tetradentate. Likewise, pentadentate and hexadentate. Polydentate ligand shows one an interesting property, that is chelation. When polydentate ligands donate their electron pairs to metal, it forms chelate ring, and such process of forming chelate ring is called chelation. It produces extra stability to the metal complexes, which will be discussed later on in some another class. There are few examples of monodentate ligand we can easily see from the table. And Another one is the some polydentate ligand. We can see here we are very familiar with ethylene diamine. So this is EN ligand whose density is 2, means it can donate, yeah, it donate 2 electron pair from two different atomic sites. Now bridging ligand and ambidentate ligand. Bridging ligand basically ligand with one or more donor sites having at least 2 electron pair which can binds with two metal ions oblique atoms. One pair with one metal atom simultaneously are called bridging ligand. Here we can see that this L ligand having two electron pairs and which binds with two different metal. One electron pair is donated to one metal and another electron pair is donated to another metal. In this ligand is called bridging ligand. From here we can see that example, this Cl act as a bridging ligand. Now there are some other examples. Both electron pair on one donor sites, like those electron pair which can be donated to different metal ion. If it is present on one donor atomic sites, then in that case it is the examples are hydroxide and chloride and amide and bromide and etc. While when both electron pair are present on two different atomic sites, then the example such as carbonyl, cyanide, thiocyanide, oxide, etc. Now move to ambidentate ligand. A monodentate ligand which have two or more than two donor sites and can coordinate to central metal atom through only one of the donor sites at a time, called ambidentate ligand. From here we can see that AB is a type of ambidentate ligand. It have two donor atomic sites A and B. When it coordinates to metal, either it can coordinate to A donor sites or B donor sites. The example is one of the example is nitro ligand. Nitro ligand having two donor atomic site, one is nitrogen and another one is oxygen. When nitrogen is linked to metal, then it is nitro, it is called nitro ligand or metal nitro complex. When it donate their electron pair through oxygen atom, then it is called metal isonitro ligand or metal O nitro ligand. There are some examples of ambidentate ligand is CO, CN, SCN, etc. Now, summary and takeaway. Coordination chemistry explain how metal form complex structures with ligand. Werner's laid the foundational understanding. Coordination number, ligand type and geometry dictates properties. A few bridging inorganic chemistry with biology, industry and material sciences. So coordination chemistry is fundamental to understanding our world from biological function to industrial innovation. Thank you.